Number 8 asks us to find all values of k such that the equation has equal roots. Now, we know if the equation is going to have equal roots, we know that the discriminant, which is b squared minus 4ac, is going to be equal to 0. So if we take a look at our equation over here, first thing we want to do with this equation is we want to set it equal to 0. So I'm going to just add 3x squared to both sides of the equation. I'm going to rearrange it in standard form. So it'll be 3x squared plus 6x plus k equals 0. So our a is 3, our b is 6, and our c is k when we plug it into the discriminant over here. All right, so let me just plug it in right underneath. We're going to have 6 squared minus 4 times 3 times k equals 0. So 6 squared is 36. 4 times 3 times k would be 12k. And what we need to do at this point is just solve for k. So I guess I'll just subtract 36 from both sides of the equation, leaving me with negative 12k equals 36. And when I divide by negative 12, I'll be left with k equals negative 3. Now, just on a side note, if the question were to have asked to find the values of k so that the equation has imaginary roots, if it had asked for imaginary, then what we would want to do is we would want to take the discriminant and we'd want to say that b squared minus 4ac is less than 0, because if you're looking for imaginary roots, the discriminant is going to be a negative number, which means less than 0. If the question had asked for you to find all values of k so that the equation has real roots, then if the roots are real, then the discriminant would have to be positive or equal to 0. So you would just take the discriminant and set it greater than or equal to 0. Number 9 just wants us to find the roots and express our answer in a plus bi form. All right, so to find the roots, we're just going to plug it into the quadratic formula. So let's first just label our a, b, and c. So a would be 1, it's the number in front of the x squared. B would be 6, the number in front of the x. And c, the constant, is 10. So if we plug it into the quadratic formula, I'll just write it out first. All right, we would have x equals negative 6 plus and minus the square root of 6 squared minus 4 times 1 times 10 over 2 times 1. Okay, so now we just want to figure out the value underneath the radical. So you just want to determine what 6 squared minus 4 times 1 times 10 is. So 36 minus 40 would be negative 4. So we're going to have underneath the radical a negative 4. So if you were to take the radical negative 4, I'll just do that off to the side, and break it up, you can break it up into a radical 4 and a radical negative 1. So the square root of 4 is 2, and the square root of negative 1 is I. So if we come back to the problem over here, we're going to have negative 6 plus and minus 2i over 2. So now you want to look at all of our whole numbers here, and you want to say what divides evenly into all of them. Well, 2. So we're going to divide them all by 2. So negative 6 divided by 2 is negative 3, plus or minus. 2 divided by 2 is 1, so we could just make this 1i, which is just I. And since the denominator is 1, we don't even have to put it. So we're left with x equals negative 3 plus and minus I. This next question asks us to solve the following system of equations algebraically. So first thing we have to do is we have to get either x or y by itself in one of the two equations. I'm going to get y by itself in this second equation here. So I'll just add 2x to both sides, leaving me with 2y equals 2x plus 2. And then I'm going to divide by 2. So when I do, 2x divided by 2 is 1x, or just x, and 2 divided by 2 is 1. So this equation transforms into y equals x plus 1. Now, since we know that y is equal to x plus 1, we can take this x plus 1 and substitute it back in for y into the other equation. So instead of x squared plus y squared equals 13, we're going to have x squared plus x plus 1 squared equals 13. So again, all we did was we took the x plus 1 and substituted it in for y into the first equation. All right, so let's solve this. So I'll bring down the x squared. When a binomial is squared, it means there's two of them. So let's just write it out twice. That way we can double distribute. All right, so bring the x squared down. And when I double distribute, I get x squared plus x plus another x plus 1, and I'll bring down the equals 13. So I'm going to actually, I know since I have x squareds, I'm going to need to get this equation set equal to 0. So I'm going to do two steps at once. I'm going to subtract my 13. I'm going to get the right-hand side equal to 0. And at the same time, I'm going to combine my like terms. So x squared plus x squared would be 2x squared. X plus x would be 2x. And 1 minus 13 would be negative 12. Now to make the equation a little easier, since everything on the left is divisible by 2, you can factor it out, but I find it easier just to divide both sides by 2. That way you just get rid of it altogether. So when I divide the left-hand side of the equation by 2, I'm left with x squared plus x minus 6. And on the right, 0 divided by 2 is just 0. So all we have to do now is factor, come up with two numbers that multiply to negative 6 and add to positive 1. So that would be positive 3, negative 2. And you're going to make a t-chart in order to solve for the x values. So over here we get x equals negative 3 and x equals 2. Now we're not done because what we have to do is find the y values that go along with these x values. So let's first find the y value that goes along with x equals negative 3. All right, I'm going to use the equation over here, y equals x plus 1, because I think that's going to be the easiest one to substitute in. All right, so if y equals x plus 1, let's replace that x with negative 3. And since negative 3 plus 1 is negative 2, we know that when x equals negative 3, y equals negative 2. So I'll write that as a coordinate, negative 3, negative 2. Now let's figure out what y is equal to when x equals 2. So I'm again going to use that equation y equals x plus 1, but this time I'm going to substitute the x with a 2. So since 2 plus 1 is 3, when x equals 2, y equals 3. So I'm going to write that coordinate 2, 3. And those are my 2 points of intersection. And I can always take both of those two coordinates and substitute them back into the original equations for x and y, just to double check that, they check.